Hello everyone, this is Hemalata, Assistant Professor, Department of Agriculture Engineering, SNS College of Technology. Here in the lecture series, we are saying about the cross drainage works. In the last two lecture series, we have seen about the introduction of the cross drainage works and the aqueduct, that is the canal above the drain, that is canal constructed above the natural drain or the streams in the where there is a mixing of the natural drains and the canal water. And as we seen about the functions and the necessity of an aqueduct, it is in the agricultural societies have constructed aqueduct to irrigate the crops. And another use of the aqueduct is to supply large cities with their drinking water purpose. It also helps to supply the water in the drought prone areas. In case of the modern civil engineering project, detailed study and analysis of the open channel flow is commonly required to support the flood control, irrigation system and a large water supply system, when an aqueduct rather than a pipeline is a preferred solution. Here coming to the Siphon aqueduct, it is a canal water is a carrier above the drainage, but the high flood level of the drainage is above the canal trough. It is the only difference. The water flow will flow under the pressure below the canal. The drainage water flows under the siphonic action, that is there is no presence of the atmospheric pressure in the natural drain. The construction of the siphon aqueduct is the flooring of drain is depressed downwards by constructing a vertical drop weir. Weir is one of the structure to constructed to stagnate the water and to discharge the high flow drain water through the depressed concrete floor. The floor, the weir will be available at the high elevation, and there will be on the downstream there is a depressed concrete floor. The siphonic aqueducts are more often constructed and better preferred than the simple aqueduct, though costlier because of this high efficiency, and it's able to capable of carrying the water under without the atmospheric pressure under at the simple ways, and there is no free flow occurs in this structure. Here the HFL is greater than the CBL, that is the canal bed level. It is one of the Siphon aqueduct constructed in the Gujarat and also in the Rameshwaram bridge. It is one of the Siphon aqueduct. When coming to the drain above the canal, it is the drain is constructed in the last two structure, that is the aqueduct and the siphon aqueduct, or the types of the canal above the drain. Here we are going to say about the drain above the canal, that is the super passage structure. In the super passage structure, there will be a necessity of this the super passage structure and the functions, that why it is necessary, what the necessity for construction of the super passage, indeed of the aqueduct and the super passage. It carries the drainage above the canal, as the canal bed level is below the drainage bed level. Here, coming to say about the necessity, the discharge of drain is small in comparison with the canal discharge. Sufficient clearance is available between the full supply level of the canal and the drain bed. In this type of the structure, the canal is not open for the inspection. Okay, there will be no ways available for the inspecting the structure, because of the drain is above the upstream of the canal. If the silt is deposited in the barrel of the structure, it is difficult to clear off. It is a superpassage structure carrying the drainage above the bed level, and the drainage stuff is to be constructed at the road level, and drainage water flows through this from upstream to downstream. The full supply level of the canal is below the drainage tuff. In this structure, the water in canal flows under the gravity and possesses the atmospheric pressure. It carries the atmospheric pressure. It is simply a reverse of the aqueduct structure. FSL is less than the drainage bed level. In the canal siphon or siphon passage, we will see in the next class. Thank you.